Hello, good morning, everybody. My name is Guillaume Calfon, talking to you from Europe, from the island of Cyprus in Europe, and ready to start this new day as far as I'm concerned. And I have the pleasure right now and the privilege to introduce to you Agrawal, who is Managing Director of Minimac Systems. And he will be talking to you now about flushing, a very important topic, including case studies. So without, I'm ready to enjoy and to learn, and I know we all are. So Anshuman, the floor is yours, but we have a small detail beforehand, which is, don't forget, we have the play to win competition, and there is a code for Anshuman's session for the play to win, and here it is. You see on your screen the code for Anshuman's session, so make sure to make a note of it. And Anshuman, I'm leaving the floor to you.
Thank you so much, Guillaume. Very warm good morning, good afternoon, and good evening to all of you who have joined here today for the LRVS session. So today's topic for us is oil flushing challenges. So we would be going through with certain case studies, and with those case studies, we would try to understand how flushing is important for our lubrication systems. So to start with, maybe we can have a detailed about myself. I'm the director at Minimac Systems Private Limited, and I'm MLE trained Korea from ICML USA. So what is oil flushing? Oil flushing is a concept where a high viscosity, sudden gush of low viscosity fluid is the components. So when do you organize flushing, and when do you require flushing? So basically you require it during the pre-commissioning phase. You require it also during the shutdown rounds of your plants. You certainly require it during the breakdown maintenance activities, and a lot more important when you do oil replacements. So many times it has been seen people ignore oil flushing when they do replacements of their lubricants. It can be either with the same lubricant, or it might be with a different grade of lubricant or a different brand of lubricant. But whenever you do the change of lubricant or oil replacement, flushing is a very important aspect out there. So we would start with certain case studies this time, and the first case studies is from Oman. Oman is a country where we have a lot of refineries around. So there was a gas compressor which was being pre-commissioned at a project in Oman. And this particular gas compressor was, the lube oil system was already pre-flushed, and it was completed with all sorts of completion parameters. So the OEM had verified it, the EPC company had verified it, the end user had verified it. So after completion of the entire flushing activity, the startup was done. And surprisingly, when the startup was done, heavy sand debris was found in the lube oil circuit, and that basically stopped the entire plant and the project. So here I would like to invite your comments. What might have gone wrong? Maybe we can check out from the audience what was the reason that even after the flushing was completed, there was heavy sand debris which was found in the system. So Kalfan, if you could just help me out if there are any responses from the audience.
Yeah, we are not saying any. We are not seeing any answer regarding this particular matter.
Okay, okay. And can you also tell me if my screen is scrolling, because I could see some chat messages, people complaining about the screen not scrolling ahead.
Right now it's not scrolling. It's also not in display mode in full screen. Now it's scrolled. We are seeing case study 1. Can you put it in full screen, display mode, PowerPoint?
Okay, I'll just share a different window maybe. Yep, so this is case study 1 where there was a heavy sand debris found after the particular flushing was already concluded. So now what was the reason behind it? Basically, the flushing was already completed, but the heat exchanger tubes, they were actually not flushed properly in the system. So here we would like to give certain insights on heat exchanger flushing. Now these heat exchangers are basically the air-cooled heat exchangers which have multiple tubes in them, and each of these tubes need to be flushed. And when you do not flush them, there would be a lot of debris which would be deposited inside the tubes. So while you are doing the flushing of heat exchangers, it's important to understand that these are multiple tubes, and if you do not calculate the correct flushing flow rate out of these particular tubes of heat exchangers, you might be doing flushing at a much lesser flow rate than what is required. So insufficient flow rate while doing the flushing of these heat exchangers might cause a lot of debris which is sitting inside the tubes. Apart from that, these tubes also have a lot of turbulators inside them, and these turbulators are, like you can see on the screen, they have certain mesh arrangement, and it is possible that a lot of debris would be deposited in these turbulators. So while you are doing the flushing of heat exchangers, it's important to remove the turbulators, carry out the flushing, and then reinsert the turbulators before going ahead for the final flushing. The next case which we have here is of a high viscosity lube oil flushing at a project at Oman again for a BP Kazan. And this project actually failed for flushing even after there was the contractor who did flushing with a flow rate of 2 times to 3 times of the lube oil pump capacity. So what might be possible is already followed 2x to 3x of flushing flow rate as lube oil pump, because the viscosity of the fluid was much higher. So just 2x or 3x might not help you, but calculate the flow rate using the turbulence Reynolds number formula is what is important out here. So this is the case which we encountered where it becomes very important, and while calculating the turbulence, you need to take care of the viscosity of the flushing fluid. And if you don't do that, if you just go a thumb rule of 2x to 3x the flow rate, probably you will miss out the actual flushing in your system. Okay, so the next case, what we have here is from the Central Asian region. And in the Central Asian region, the temperatures, they were actually sub-zero. And the entire flushing was happening in an environment or in ambient conditions where the temperatures were less than 10 degrees centigrade. So what happens is when you bring out or maybe you hire certain flushing systems from other countries, probably those will not be tropicalized according to the environment where you would be working with. So the flushing skids normally need to have certain heating devices, and those heating devices would enable you to raise the temperature of your oil up to certain degrees. And then if you carry out the flushing, the viscosity would be lowered temporarily, and then you would be able to achieve some better flushing efficiency for your lines. Another important tip out here is if you could see, there are some insulations which are needed in the pipelines or the loops which you are wanting to flush. So these insulations are very important because when you start doing the flushing activity, there would be a certain temperature fall which will happen because you have not insulated those pipelines. So tropicalization and insulation of pipelines is important when you actually go for flushing in ambient conditions which are highly severe and you have sub-zero temperature ambience. Okay, so the next case what we have here is it's from a steel plant. And a steel plant in India, where I belong to. Here there was certain turbine blower flushing which was being carried out. And in these turbine blower flushing, the client or the EPC company, they actually concluded the flushing by checking the NAS 1638 results and also the ISO 4406 results. So what happened is, even after checking the results and concluding them based on these parameters, they started the turbine blower, and the day they started it, it actually got tripped for the reason of heavy debris found on the dew play filters of the lube oil system. Now they all scratch their head, where did this entire mug come from? Because they have already checked the NAS class, they have checked the ISO values. So they were completely confused, and it actually lost some 5 to 6 days of their valuable project time. Now, what was the reason? The reason was that the testing of NAS standard and ISO 4406 standard, it happens on a very small amount of oil sample, probably half a liter or maybe less than that. And the amount of oil which is taken into the laser particle counters is even less than 100 ml. So in those scenarios, it's not the full flow representation of the flushing. So what is recommended is you need to have certain mesh screen inspections, like you could see in the pictures out here. So when we actually took up the project out here in the steel plant, we immediately went ahead for a mesh screen inspection. And these mesh screen inspections showed a lot of debris because they carried the entire full flow of flushing downstream flow. And that flushing downstream flow had heavy amount of sand and mud particles, and those got trapped in these mesh screen inspection methodology, and thereby we could understand there is still a lot of mud which is getting generated in the system. The second thing what we did out there was to increase the flow of flushing. So previously the flushing was happening at a much inadequate flow rate, and that's the reason why the mug from the various internals was still getting generated. So using the API mesh screen is the takeaway from this particular case. It's very important. So once you do the primary inspection using the API mesh screen, you can proceed with the other tests, that is NAS and ISO 4406. So in all, I would like to conclude my presentation with some successful flushing tips. So I was recently, I had posted a post on LinkedIn that I came to know about flushing, and I was motivated about flushing when I actually used myself in washing or cleaning my baby's milk bottles. So yeah, when you do some household stuff, you actually come to understand a lot of ideas by which you can actually solve some bigger industrial needs and problems. So there are some 5 steps or 5 tips which you actually can follow for doing a perfect flushing for your lubrication system, which are the first one is flushing flow rate. If you can manage a good flushing flow rate as according to the turbulent flow using the Reynolds number formula, I think you will achieve the task. While you're doing this, you need to take care of the viscosity as well. So viscosity needs to be as low as possible, and if you can maintain it by using certain heating devices on your system, there's nothing like it. Filters or efficient filtration system while you're doing flushing is again very important. By efficiency, I mean to say the micron rating, the life of filters, and also the flow rate of filters. I've seen on a lot of sites people using lower capacity of filters, and then they scratch their head off on how to replace these filters again and again and stop their flushing activity. So have adequate size of filters, have efficient micron ratings of filters, and have a good sized filters for the right flow rate of flushing. Thermal shocks or certain temperature variations, yes, that's very important for loosening the mug or the debris which is sitting on the internals of the pipings, and the duration of flushing. So that's again very important, because if you conclude your flushing midway, you are actually going to lose a lot of project time later on. So I can see there are a lot of sites where people are hard pressed for closing the site and commissioning the entire project as fast as possible, because that's a payment milestone for them. But what I can comment here is, if you cut short the duration of flushing, the wrong means or certain malpractices, that would actually come back and boomerang on you, and later on you would have to spend much more time and much more manpower and resources on concluding the flushing later on. So that's what I can say here is, the flushing is the first step of the reliability for any lubrication. Make it mandatory, not an option. That's all from my side. Thank you very much. I'm sorry for the glitch we had. I hope that. Thank you so much. Over to you, Calvin.
Thank you, Anshuman. Thank you. A very concise, practical presentation regarding how to conduct flushing. And okay, I'm getting some echo. I hope it's not affecting anyone else. And I do have some questions coming in from the audience. So the first one we take is this one here from Dugard. How do you make the lesser amount of flushing oil stay in the circuit? How do you make the lesser amount of stay?
The choice of flushing oil which is compatible to the tube oil system oil which you are actually going to pour in tomorrow. So that's the first step you need to take out while you're selecting the flushing oil. But if you want to the entire flushing oil from nitrogen purging is an option that you can adopt. So in your flushing loops, you need to have certain points or ports wherein you can purge the nitrogen from a good drain system, from where the flushed oil will come out, and you can collect it and dispose it, or you can reuse it for another system. I hope that answers your concern on the.
Can you repeat the first point, because the sound wasn't so clear from my end?
Okay. So basically, you choose a flushing oil which is compatible to the lube oil system oil which you actually want to pour in tomorrow. So the first thing is to have a compatible flushing oil.
And Dugard's question was regarding the quantity of flushing oil used. How do you keep it in the circuit if it's a lesser quantity?
Right. So I believe what he wants to say is the stagnant flushing oil which would remain in the system once you have concluded the flushing. So for that, you would need some nitrogen purging devices, and you could use some ports on the flushing loop. With that, you can purge the high pressure nitrogen into the system, and that would actually solve the problem. While you are doing this, it's important for you to actually take care of the nitrogen which you are pouring inside the system, because that should not hamper the entire flushing activity what you have done. But the first point was more relevant out here. You use the flushing oil which is compatible to the lube oil system, so that even if flushing oil remains in the system, you don't have to worry about that.
Okay, for the audience, I will start with more general questions and go down to more specifics later. And so the first one that I think is of interest to everyone will be this one from Preeti, which is how to calculate the duration of the flushing.
Okay. So basically, if you want fracture, I believe you time that you would like to spend on your flushing, and you would like to know the duration of flushing. Now, calculate experience. Calculate the duration. If you want to know based on a compressor around 4 days to 10 days to complete the flushing. It's not just about the but also about and infrastructure which you if you have ready with probably you earlier
So for rule of thumb, sorry again, sound is breaking up a bit. Rule of thumb for compressors, you said 5 to 7 days. Sorry again, sound is breaking up. 5 to 7 days. Okay. So everybody. So I know we're having a bit of a breakup in sound. I hope it's still coming through clearly. So how regarding turbines flushing, what would be your idea of recommendations regarding best practice for intervals for flushing?
right. So hi Pathir, I think you are using certain gas turbines. So with those, you have many concerns with regards to varnish, which get deposited over time. So if you have any of those concerns with varnish in your system, I believe you would require flushing at a high interval. The ideal time doing is when you have a turnaround for your standard rotary equipment, you carry out flushing. That would be the best for yours.
Okay, now a question from Yogesh. So using the same flushing machine, how do we adjust the oil velocity?
Okay, great question. So basically, with the same flushing machine, if it's an external flusher, you could actually generate various flow rates. And when you generate various flow rates, and these flow rates go into various diameters of the loops, they would create different oil velocities. So you could have certain manifold system in your flushing machine or the flusher, and with those manifolds, you could serve multiple loops at the time, and you could generate different flow velocities and basically the flushing flow rates.
Okay, from Mahir. Question regarding the suitable temperature of oil used for flushing. I suspect it will not be one for all applications, but my opinion matters a lot less than yours. What's your recommendation on this?
So, for a normal lube oil, you could actually go for a temperature of around 60 degrees centigrade as a maximum when it is in use. But for flushing, as the oil won't be used as a lubricant later, you could raise the temperature up to 80 degrees centigrade in certain cases. Now, you need to decide the temperature based on the viscosity of the fluid that you're using. Maximum 80 degrees is the threshold you can go ahead to, but the decision would actually be based on the viscosity of the fluid being used for flushing. So thermal shock also temperature, which is important. So based on the heat exchangers and he decide whether you have to go for 80 to 40 degrees of variation, or you have to go for 60 to 20 degrees of a variation for the thermal shocks.
Okay, going into a more specific question from Can you share something about experience of flushing EHC systems?
Yes, in fact, that's a vital system because EHC actually in the market I have seen catch values or total numbers very fast. And over time, they also catch bonus like that. So while you are doing any kind of turnaround maintenance or scheduled maintenance with the EHC system, it's very important to carry out. These are systems EH as so this has its own. So whenever you are doing flushing for the EHC system, it's better you carry it out with the same flushing fluid that will be used for the hydraulic system later on.
Okay, also somewhat more specific one for particular piece of equipment. And this one is from Jesus. So I don't know if you have this experience yourself. Have you come across flushing of wind turbines, and what particular recommendations regarding these?
Yes, we have certain experiences with the gearbox, and these manufacturers actually do the flushing of the wind turbine gearboxes before they are dispatched to site, and the level of contamination cleanliness which they want to achieve is NAS class 4 or 5. So that's something very, very high in terms of contamination class. The reason is because it's very difficult to maintain the wind turbine gearboxes. They are at a certain level where you can't go again and again and do the maintenance. So right from the manufacturing stage, the gearboxes of wind turbines are flushed. Once they are on the nacelle and they are in service, it's very important to purify the gear oil on a regular basis. If you do that, and if you have the correct purification systems, and if you're following the right practices, probably the flushing won't be required at a very high interval, because these gearboxes are normally in a scenario or in an environment where dust is not very high. But yes, there are certain uncertainties in the usage of these gearboxes, in the entire pattern of loading on these gearboxes. So there might be certain wear and tear cases for which the contamination would get generated in the gearboxes. So that's why I recommend you to go for a complete purifier which can take care of the contaminations which are generated in the in-service of wind turbine gearboxes. But with regards to flushing, probably it would not be very easy to keep on flushing the gearboxes every now and then.
All right, now we still have a couple of minutes. To reach the end of the session, I will have to end it because the whole conference needs to stay on time, of course. And so this is a very broad question. Conference needs to stay. Can you cut to the essentials of what are the parameters to be considered when flushing lube oil lines and equipment? Cut to the from Sagar. Essentials of what are the parameters?
So, with regards to the parameters, when you're doing the flushing, you actually check it. You need to check the NASA experience 406. The endpoints which are mentioned on every flushing manual of the manufacturers and the EPC companies. So, if the flushing activity would
Okay, we are reaching the end. We have less than 1 minute to go. So thank you so much, Anshuman. I really enjoyed this and learned a lot on this complicated topic and essential. I see it generates a lot of interest and passion and questions. So everyone in attendance, don't hesitate to make contact with Anshuman after this conference and carry on the discussion and the request for information. And Anshuman, thank you very much and see you later. Bye-bye.